All right. Question 5, Physical Sciences Paper 1, Free State, September 2024. Okay. They're saying a small block of mass 0.4 kilograms is released from rest. So the initial velocity of that block is equals to 0, and the mass is 0.4. At point A, there is point A, okay, which is 0.8 meters vertically above the ground. So what is that 0.8 meters? That is our height, right? To be more specific, that is our initial height. Okay, if we are looking maybe the path A, B, A, C, all right, okay, and also AD. Okay, then they are saying it takes the block 3 seconds to slide down from point A to E, okay, when it comes to rest. So the velocity of the object at point E is going to be equal to 0, okay, because it comes to rest. All right, and then they are saying now they are saying the length of the track from A to E is 8.1 meters. So that is the displacement from A to E, and then they are saying point D is 0.3 meters vertically above the ground. That is the height at point D. Okay, and now they are saying the surface of points A to D is frictionless from A to D, frictionless, right? I think we can see, because if we compare the surface, it's smooth compared to DE. The surface is rough there. So this surface is frictionless from A to D, frictionless. In other words, there is no friction, and remember, friction is a non-conservative force, and immediately when there is no friction or no non-conservative force, then the mechanical energy is conserved. Okay, and then points D to E have a rough surface, and then they are saying ignore the effect of air resistance. And then 5.1, they are saying state the principle of conservation of mechanical energy. State the principle of conservation of mechanical energy. All right, so when we state the principle of conservation of mechanical energy, we are saying the total mechanical energy in an isolated system is conserved. Okay, total mechanical energy in an isolated system is conserved. That is for 2 marks. All right, then we can therefore move to the next question. The next question, let's see, right, that is 5.1, right? So 5.2, it says is the kinetic energy at point B the same as that at point C? Okay, at point B, is it the same as that at point C? Right, only yes or no. Okay, so let's think about it. Remember, from A up until D, there is no friction, so it simply means that mechanical energy is conserved. Why we say mechanical energy is conserved? Because there is no energy that is lost from A to C. So is kinetical energy at point B the same as that at point C? Yes, that is the answer. Yes, right? And then you're going to say give a reason for the answer to question 5.2. You can say there is no friction, or you can say there is no non-conservative force, therefore no energy is lost, right? And then 5.4, use the energy principles to calculate the speed of the block as it reaches point D. So now when they're saying energy principles, there are so many energy principles. Okay, we have work energy theorem, we've got mechanical energy principle of conservation of mechanical energy, we've got work done by non-conservative force, we've got work done by conservative force, but we only need to use we only need to use one, right? Yes, we only need to use one energy principle from those energy principles in order to calculate the speed of the block as it reaches point D. Alright, so which principle can we use? Definitely we can use the principle of conservation of mechanical energy, because from point A up until point D we said that there is no friction, and if there is no friction then mechanical energy is conserved. So let's try to use the principle of mechanical energy in order to calculate what is required. So we are going to say mechanical energy. Okay, we can say the sum of the mechanical energy. Let's say sum of mechanical energy before is equals to the sum of mechanical energy after, right? In fact, there is no need for this, because now I will be left with space there. So we can say mechanical energy before is equals to mechanical energy after, right? And we know that mechanical energy is the sum of kinetic energy and potential energy. So I'm just gonna say EK before plus EP before is equals to EK after plus EP after, right? Then EK initially, when we manipulate that, we know kinetic energy is equals to half mvi squared in this case. So it's going to be half mvi squared plus potential energy is going to be equals to mass multiplied by acceleration due to gravity multiplied by height, but initial height to be specific. Then we do the same with what is in our right hand side, but remember we are dealing with final, right? We are dealing with final, so it's going to be half mvf squared, right, plus mgh final. Therefore we can do our substitutions, right? So let's go back here. So they said our the block has a mass of 0,4, right? And then remember it was released, so it simply means that initial velocity is equals to 0, right? So let's try to substitute here. So it's going to be half into 0,4 multiplied by 0 squared. And if you multiply this, half 0,4 multiplied by 0 squared is going to give you 0. So let's just write 0, because kinetic energy initially is 0 because of that initial velocity of 0, right? Plus mass 0,4, acceleration due to gravity, that is 9,8, and then initial height, I think it was 0,8. There is our initial height, so it's 0,8. Remember we are looking for what? We are looking for the speed at point D, right? So our initial height is 0,8 and then our final height is 0,3, right? So we're going to substitute 0,8 is equals to half into mass is 0,4, final velocity, that's what we are looking for, and then mass 0,4 multiplied by 9,8 multiply, sorry for that, but that is 0,4. Okay, let me try to write it here down there. So it's 0,4 multiplied by, that is 0,4 multiplied by 9,8 multiplied by our final height, which is 0,3. So you can multiply by 0,3 there. Sorry about that, but that is 0,4 multiplied by 9,8 multiplied by 0,3, right? So we just substituted mass, acceleration due to gravity, and also final height. So let's do our calculations. So if we multiply 0,4 by 9,8 by 0,8, 0,4 multiplied by 9,8 multiplied by 0,8 is going to give us 3,136, which is equals to, then if you multiply half multiplied by 0,4 multiplied by vf squared, it's going to give you 0,2 vf squared, and then down there 0,4 multiplied by 9,8 multiplied by 0,3, 0,4 multiplied by 9,8 multiplied by 0,3 is going to give you 1,176. Right, then you can transpose. When you transpose, obviously you will bring this one to the side, then it becomes 3,136, right, minus 1,176, right. So you bring this to the side, then changes to sign, remember, and then you will be left with 0,2 vf squared, right. So you can therefore do your calculations. 3,136 minus 1,176. This is giving us how much? 1,96, right? So it's giving us 9, not 9, but rather 1,96. Then you know, after that you will be left with 1,96, which is going to be equal to 0,2 vf squared. Then from there you then divide the answer that you got by let's try to write it down. Yes, this is 3,13 minus, right. Why did I write this now? So this is what is happening basically, right. And then 3,136 minus 1,176 is giving us 1,96, which is equals to 0,2 vf squared. Therefore we can just divide by 0,2 on both sides. This is not 6 here, but it's 0, so 0,2, 0,2, and then this cancels this, then our vf squared is equals to 1,96 divided by 0,2 is equals to 9,8. Therefore you want to be left with vf instead of vf squared. So how do we remove that square? We just introduce the square root on both sides, and when we do so we will be left with vf, and then the square root of 9,8 is equal to 3,13 meters per second, and that is the final velocity at point D, right. The velocity at point D, that's how we do that question. And then the last question, which is 5.5, let's see what does it says now. Okay, here's it. So let's see. It says that the distance between D and E, so let's go back to our sketch. The distance between D and E, right, there is D and E, and can you see that the surface is now rough? So it simply means that there is friction, and friction is a non-conservative force, right. So they are saying the distance between D and E is 3 meters. So that is the displacement between D and E, right. So we know that displacement is represented by delta x. So delta x is equal to 3 meters, right. And then use energy principles to calculate the magnitude of the frictional force acting on the block between D and E. So what are we looking for? We are looking for the magnitude of frictional force. So now, because now the surface is rough at D and E, we can never use the principle of conservation of mechanical energy from D to E, but we can maybe try and use work energy theorem, right. Work energy theorem, we do have velocity here. It was final velocity, but when we focus on D to E, it is no longer our final velocity, but it's our initial velocity, right? The velocity that we calculated on the previous question 5.4, right? So when we focused from A to D, it was final velocity, but when we focus from D to E, it's no longer final velocity, but it is initial velocity. So we found it to be 3.13, right? And then here we are saying final velocity is equals to 0 because they said it's going to come, okay? And what did they say? They said at point B it comes to rest. Yes, that's what I'm trying to say. So we can use the work energy theorem, right? Work energy theorem, which says that W net is equals to change in kinetic energy. And now because frictional force is the only force that in this case that act on the surface GE, it simply means that it is the only force that does the work, right, from G to E. So we have work done by frictional force from G to E. So we'll just substitute work done by Fk is equals to change in kinetic energy, right? And then work done by frictional force is going to be frictional force, kinetic frictional force, right? To be specific, you will just substitute kinetic frictional force multiply by delta x, which is the displacement, multiply by cos theta, right? Cos of theta. And then let's manipulate change in ek, that is half m into vf squared minus vi squared. All right, then we can therefore draw our calculations. Remember, we are looking for Fk, and remember they said the displacement is equals to 3. That's what they said, right? Of course, that's what they said. So we will substitute we will leave Fk as it is because that's what we are trying to look for. And then delta x, that is our displacement, so we'll substitute the ray because they said that is 3, and then cos of theta. Now this angle, the confusion is on this angle. This angle simply represent the angle between the direction of the force and the direction of the motion, right? So because now frictional force opposes the motion, so let's substitute the ray there. Because now frictional force is the force that opposes the motion of an object, we will just write cos of 180 degrees because it opposes the motion of an object. So theta is going to be equals to 180 degrees, right? Because frictional force opposes the motion of an object. So the confusion is always with that theta. So please note that that theta simply represent the direction of the angle between the direction of the force and the direction of the motion, right? So we'll substitute 180 degrees is equals to half into the mass, remember is 0.4, and remember we set our final velocity is 0, so we'll just say 0 squared minus, and then our initial velocity from G to E, remember our initial velocity is 3.13, right? So we will substitute 3.13, then we square that. Okay, so this is how it is. So that is 3.13 squared and another bracket. Okay, so Fk multiplied by 3 multiplied by cos of 180 degrees, that is negative 3 Fk, right? Because cos of 180 degrees is simply equals to negative 1, right? So when we multiply that, Fk multiplied by 3 multiplied by cos of 180 degrees, this is going to give us this is going to give us negative 3 fk, right? So now let's see. Then on our right hand side rather, we have, yes, negative 3 fk is equal to on our right hand side we have half into 0.4, right, into 0 squared minus 3.13 all squared, right? Then this is going to be equals to negative 1,95938. Therefore we can just divide by negative 3 on both sides. Alright, and then fk in this case is equals to how much? So negative 1,95938 divided by negative 3, this is equals to 0.65 newtons, and that was 5.5, right?